Hello and welcome back. We are discussing slab spanning in two directions as per IS 456-2000. I hope you have seen my previous video wherein we had discussed few fundamentals regarding design of two-way slab as per table number 26. Let's revise this very quickly so that we can proceed for the problem. As per the recommendation given by the code, the slab panel is actually divided in two strips in both the directions. They are called as a middle strip and an edge strip, which is 3 by 4th of span and 1 by 8th of the span respectively in either directions. Bending moments are basically calculated based on these two formulas expressions given in the code, like mx is alpha x into w into lx effective square and my is alpha y into w into lx effective square, wherein these alpha x and alpha y values depend on ly effective to lx effective ratio for various end conditions, which are 9 in total for two-way continuous slab. If you closely observe, short span coefficients are given for various ratios of Ly by Lx, and alpha y is constant for all the values of Ly by Lx ratio. Most important thing is to locate the locations of alpha x and alpha y, for which I think we had discussed this in the previous video. We will quickly revise this. Suppose I am having the interior panel of a slab and I take a very small finite element of the slab panel. This slab is having continuity in all the four directions and it is having longer span Ly along x direction of the current plane and shorter span Lx in the y direction of the current plane. Now when this small finite element of this slab panel bends in the sagging manner, the bending of a long span in sagging manner will induce a negative bending moment at shorter span. This is in consistence with any of the structural analysis course wherein you might have done a continuous beam. In the analysis of continuous beam, we all understand that when there is a sagging bending moment at midspan, there is a hogging bending moment at continuous support, which follows like this. Therefore, positive bending moment of longer span will induce a negative bending moment at shorter span, and similarly positive bending moment of short span will cause a negative bending moment for longer span. This is the basis for your alpha x coefficients for positive as well as negative, and alpha y coefficients for positive as well as negative. If we understand this, then we can solve any problem and design any slab. For example, let's take this particular slab system wherein we have 9 slabs in total. All slab panels are having 5 meter as the longer direction or the longer span, which is parallel to the x direction of the current plane, and they have shorter spans parallel to the y direction of the current plane, which are having two shorter spans. Two slab panels similar are having 3 meter short span and the other one is having 4 meter short span. Now this slab system is having a continuity at some edges and discontinuity at some edges. We will have to classify these slabs based on the conditions given in IS 456, which is in table number 26. I have already classified them and grouped them as per their end condition. Now if you check this slab panel S3, it is having two adjacent edges discontinuous and two adjacent edges continuous. Now where this falls we'll have to see. As I written here, this belongs to case 4. We'll read what does the case 4 say. Now this is the case 4, which states that the two adjacent edges are discontinuous. For that you will have negative bending moment at continuous edge and positive bending moment at midspan, which is absolutely similar to any continuous beam that you take. Always a continuous beam system or slab system will have positive bending moments at span and negative bending moment at continuous edge. Now for this slab panel, which is belonging to this particular case, that means two adjacent edges discontinuous, we are having short span coefficient for positive as well as negative for various values of Ly by Lx ratios, and only one value for positive and negative alpha y value, which is a coefficient for long span. To calculate these alpha x and alpha y, we need Ly by Lx ratio, so that if we can get Ly by Lx ratio, we can interpolate between the values to get our value of alpha x and alpha y. This is for slab panel S3. So all slabs which are in corner they are having two adjacent edges discontinuous. So they all belong to case number 4, and we will mark them as a same letter, that is slab panel S3. Now if you check this slab panel S1, it is having 3 edges continuous but 1 edge is discontinuous. But we will have to identify which edge is continuous or which edge is discontinuous particularly. Now if you check, 4 meter is the short span and 5 meter is the long span for slab panel S1. Therefore, we can conclude that this 4 meter side is discontinuous, that is the short side of this slab panel is discontinuous. So we will have to search for this particular case. Now I have already written this belongs to case 2. Now we will read what does this case 2 say. Case 2 is one short edge discontinuous, not continuous. This is printing mistake. For that, I again have negative bending moment at continuous edge and positive bending moment at midspan. Similarly, alpha x and alpha y both positive as well as negative. Now if you check this internal slab panel, it is having continuity in all the directions. So it is interior panel which belongs to case 1. We will read again in the code. This is the interior panel which has continuity in all the directions. So it will have negative bending moment at all continuous edges and positive bending moment at midspan. There is only one interior slab panel. Now if you come to slab 2, now if you can check, it is again having 3 edges continuous and 1 edge discontinuous. Now if you check, this long edge is actually discontinuous and all other edges are continuous. Now we will have to search for the case. Again I have written it is belonging to case 3. We will read what case 3 say. The case 3 reads like this. It is one long edge discontinuous and we have positive as well as negative bending moment coefficients for alpha x and alpha y for shorter and longer spans respectively. There are 2 such slabs which are having long edge discontinuous. So now we have grouped them as per their end condition enlisted in table number 26. Now based on this, we will have to identify the coefficients alpha x and alpha y, which may be positive, which may be negative depending on where it is acting. From continuous beam analysis, we all understand that slabs will have positive bending moments at midspan and negative bending moments at continuous edges. For the time being, let's focus on positive bending moments only. It is very important to orient our coefficients along their respective directions, because that will give us the direction of the bending moment and direction in which our main reinforcement should go. If you can relate this with a one-way slab, just for example, now you understand that main reinforcement should go along x direction. So bending which is occurring along shorter span, the reinforcement must go along the shorter span, wherein if bending moment is along longer span, then reinforcement must go along the longer span only. So this is very important step for defining our reinforcement pattern or bending moment pattern, which we can later compare. Therefore, I am orienting my alpha x plus, which is for midspan bending moment, and it is oriented along Lx. And this alpha y plus is oriented along Ly. I do this for all the slabs. For now, if you check slab panel S1, Lx is the 4 meter side, so I am again orienting this along the y direction of the current plane, and alpha y positive is actually the longer span coefficient, which is now along the x direction of the current plane. Similarly, we can do this for all the slab panels. Remember that the dimensions given are end-to-end, that means they are clear dimensions, and each slab panel is supported by 230 mm beam. Now locating positive bending moment coefficient is fairly easy. The real challenge is to locate negative bending moment coefficients. For that, again we will go back to our this diagram, wherein we understand sagging bending moment of long span induces negative bending moment in short span, whereas sagging bending of short span induces negative bending moment in longer span. So if we can follow this, we can find negative bending moments and their orientations. Remember, negative bending moments will occur only at the continuous edges. So if these two are the discontinuous edges, there is no bending moment occurring or no negative bending moment occurring. But now if you check bending of short span of S3 panel, if you check as per the direction of this cursor I am showing, if short span bends in the sagging manner, it will induce a negative bending moment along the longer span. Therefore, alpha x negative will occur at this edge and the orientation will be along Lx direction only, which is indicating that this particular edge is actually bending in the sagging manner, wherein we'll have to provide reinforcement like this, which can only erase the bending of this particular edge in hogging manner. Similarly, now if you can check, this slab panel S1 is having continuity at all three edges. Now if you can check, this is the short span. When short span is bending in sagging manner, long span will receive a negative bending moment because it is bending in hogging manner. Similarly, if long span is bending for this particular slab panel, now sagging bending of this particular slab panel will induce a negative bending moment at short span. Therefore, it will have alpha y negative coefficients oriented along Ly, but it is giving bending moment to short span. Now from this orientation you can understand this particular edge is bending in hogging manner. So if you provide reinforcement along this direction, it will arrest that particular tension which is occurring at top. Similarly, let's go to slab panel S4, which is having continuity in all directions. Now again we can check this Ly is the current plane direction x. Now Ly, if it is bending, rather in other words, if I say the long span is bending in sagging manner, then it will induce a negative bending moment at its continuous edges in short span. So you can follow the cursor. Now you can see this is hogging, then it is sagging, then it is hogging. Therefore, we'll have negative y coefficients acting along the shorter span, and similarly when the short span bends, now again you can follow the cursor, it is now hogging, then sagging, then again hogging. So S4 is having negative alpha x along the continuous edge of or longer direction. Therefore, we can orient all our alpha x negative, alpha y negative, and if we superimpose this, we can get positive as well as negative coefficients in all the directions in one diagram. Now this is how our slab panel looks, or slab panel system looks. All slabs are having positive bending moments at span and negative bending moments which are oriented properly along their long span and short span respectively. Now calculation of these positive and negative bending moments we shall continue in the next video. Don't forget to watch, and if you like, please subscribe. Thank you. See you in next video.